In this video, we will solve a function and we will find the minimum of that function using golden section search method. So let us see the problem. So the problem says that the function is f of x square. F of x is x square plus 54 by x, where a is 0 and b is 1. Okay. So we will find the solution, or we will find the minimum. So I can draw the number line where a equal to 0 and b equal to 5. Okay. Now we will investigate the minimum of this function, and we will perform 3 iterations to understand the method. Okay. So what to do first? If there will be any interval, then what to do in this golden section search method? We have to convert, or we have to normalize this interval. So what is the function? So function is w equal to x minus a by b minus a. Okay, this is the function. So if I put the value, then if I put a equal to 0 here, a equal to x equal to a, then it will be 0, and x equal to what? B, then it will be 1. So we will get aw equal to 0 and bw equal to 1. But what is the value? So it will be x minus a is 0 by b minus 0, that is b minus a is 5 minus 0. So that implies w equal to x by 5. Okay. Now if this is our value, then what is x? X will be 5w. Okay. So now the new function will be fw. So fw will be 5w whole square plus 54 by 5w. Okay. So this is our function. Okay. So now we will use this function and we will find two values, that is w1 and w2. So w1 is aw plus 0.618 into L, okay, or LW. So here LW is what? 1, and W2 equal to BW minus 0.618 into LW. So LW will vary in each iteration. Okay. Now, so first iteration we will do. So iteration 1, what will happen? We have to construct W1 and W2. So W1 here it will be AW is 0 plus 0.618 into what? LW. So LW is nothing but 1 value. Okay. Similarly, so it will be 0.618. Okay. That we got here. Like W2 will be what? This is BW minus 1 minus 0.618 into 1. LW is 1. So it will be 0.382. So based on this value, we have to find the FW1 and FW2. So here we see that this is 0, this is 1, and W1 is, this is W1 0.618 and this is 0.382. Now we saw that f of W1 is 27.02 and f of W2 is 31.92. So f of W1 is less than f of W2. That means if f of W2 is more than f of W1, then what will happen? At this value, at this x, the function value is more, that means we have to delete this portion. If we delete this portion, what portion will left? 0.382 and 1. So for the next iteration, okay, what will happen? Our a will be 0.382, okay, 0.382, and our b will be 1. Okay, that means AW here, AW equal to 0.382 and BW equal to 1. So by using this interval, we will find again f of W1 and f of W2. So W1 will be same formula. This formula we have to apply, but here AW is this, BW is this, and LW will be what? 1 minus 0.382. So in this way we have to find. So W1 will be this 0.764, W2 will be what? 0.618. So based on this we will find function value. So f of W1 is 28.73, f of W2 is 27.02. So f of W1 greater than f of W2. So if I draw the number line, so what will happen? This is AW 0.382, then this is BW1, and W1 is this one 0.764, and W2 will be 0.618. So we saw that f of W1 is greater than f of W2, and f of that means at this point function value is more, so we have to delete or we have to cut this region. Okay, then we have to find iteration 3. For iteration 3 we have this region. So for this region, what AW value will be 0.382, BW will be what? 0.764. So based on that we will find LW is 0.764 minus 0.382. Okay, like that. Then we will calculate W1 and W2. So W1 is 0.618, W2 is 0.528, and we see that f of W1 is 27.02, which is less than f of W2. So here f of W1 is less than f of W2. So this thing we can show in number line. So this is A value, AW value is 0.382 and BW value is 0.764. Okay, so based on that we have W1 and W2 value. W1 is 0.618, so it will be 0.618, and this will be 0.528. Okay, and we saw that f of W1 is less than f of W2. Okay, that means 0.528 it will be more. So at 0.528 function value is more, means we have to delete this region. Okay, then finally what we got 0.528 to 0.764. So our new AW will be 0.528 and new BW will be 0.764. Okay. So after 3 iteration, what we saw? We saw AW equal to 0.382 and BW equal to 0.764. Okay. Now what is the actual bracket where the minimum lies? We have to find through this AB, means we have to find through these functions. So we know W equal to x by 5. So as we know that AW and BW, so now the new x value will be what? We know x equal to 5W. So now new x will be what? 5 into 0.382. Okay, this is A. Okay, or new A, then new B will be what? 5 into 0.764. So this is our new A and B, or this is our desired value. That if it is star 1 and if it is star 2, then what we say? We say that our minimum lies between star 1 and star 2. Okay. So So this is the final solution of this problem after 3 iterations. So based on this stopping criteria, we have to extend our iterations and then we'll stop. Okay.